So hi everyone, welcome back to my channel. I am here back with another binary search question, and today we would do how to implement an upper bound. So if we understand the problem statement, we are here given with the sorted array and which would contain n integers and an integer x for which we have to implement the upper bound. So let us first understand that what does an upper bound means. So I have written a definition here that upper bound of an element is the index of the first element that is strictly greater than the given element. Now the word strictly greater plays an very important role. Now if we are given with the target element x for which we have to find the upper bound, then the element should be greater than x means we need to return the index for which the element is strictly greater than x. It need not to be equal to the target element. So let us first understand this by an example. I have taken an array here with the index 6 and it's a target element of 2 for which we need to find the upper bound. So let us iterate in the array. So what the first index is 1 and is we need to check that is 1 is greater than 2. No, it is not. We move, we check that is 2 greater than 2. No, it is not. So we again move, it's 2 greater than 2. No, let us again check 2. No, it's not greater than 2. Now we move to index 4. We can clearly see that 4 is greater than 2. So we can say that 4 is the upper bound of 2 and we can return its index which is 4. Now let us change the target element to 3. So I have taken an example here that 3 is not present in the array and we are given in the definition that we can find the element which is strictly greater than. So if the element is either present or not present in the array, its upper bound can exist. So let us check for the upper bound for 3. Is 1 greater than 3? No, it is not. Is 2 greater than 3? No, again it is not. Same for these all two. Now we move to the 4. Is 4 greater than 3? Yes, it is. So we can return the index for the this fourth element which is again the index 4. Now let us change the target element to 7. Now we check for again in the array, we traverse in the array, we can see that there is no element which is greater than 7, that is our target element. So we can return the size of the array, we can return n. So here the n is 7, so we would return the 7 to the answer. So the brute force way to solve this solution can be linear search, in which we can traverse every element and we can apply the condition that is the element is strictly greater than the given element or not. If it is, then we can return that index. If it is not, then we can return the size of the array. But it is clearly stated in the question that we need to write a solution that runs in a logarithmic and time complexity. And we know that linear search runs in a time complexity bigger often for the worst case. And the clear solution, since the array is sorted, we can clearly apply a binary search here. So let us apply a binary search here. If you have not checked the first video for the binary search, please check it out because without it you can't understand how this binary search would be implemented. So I have taken 3 pointers here, low, high and mid. So we know that the low would always be placed at the first index and the high would always be placed at the last index. Now we need to calculate the mid. How is mid calculated? Mid is calculated by taking the sum of the low, which is the 0th index, plus sum of the high index, which is 6, gives 6, and we would divide it by 2, which gives 3. So mid would be placed at the third index. Now we would check our condition, that is the middle element greater than the target element. No, it is not. So we can say that every element on the left search space would also be lesser than this middle element. So we need to trim down our search weight to middle plus 1. We can trim down our search space to the right search space. After that, we would again calculate our mid, which would be 4 plus 6, which gives 10, divided by 2 is equal to 5. Now we will place our middle element at the 5th index. Now here we can see that middle element is greater than 2. We can say that it can be our answer. So we can store answer variable, we can store fifth index here, but we need to find the first element that is strictly greater than the target element. So we need to trim down our search bit to get the smallest possible answer. So we need to place the high at mid minus 1. Now we will again calculate the middle, which is 4 plus 4, which is 8 divided by 2, which again gives 4. So middle would be placed at the fourth index. Now here we can see that mid is placed at the fourth index and 4 is also greater than 2. So answer would be updated to means fourth index. Now we can say that there may exist an answer, so we would move the high pointer at mid minus 1, and here we can clearly see that the high crosses the low, which ends the search space, which the while condition get broken, hence we would return the answer at the last. So this is a clear explanation for upper bound. Now we will code the solution quickly. Okay guys, I am here solving the question on code 360 by Coding Ninja. You can also try for the same, and let's code it up quickly. The one condition that I need to explain is that if the greater value does not exist in the answer, then we can return the size of the answer. So in the starting, if we can say that if the answer does not exist, we can return the size of the array. After that, we would take our low pointer on the 0th index and we would take our high pointer on the last element. After that, we would simply apply our binary search as usual. We would calculate the mid, which is equal to low plus high divided by 2. After that, we would check the condition for the upper bound, that is if array of mid is greater than x or not. If it is, then we can store the answer in mid and we would trim down the search space to get the minimum element possible. If it is not, then we can say that the element would be present in the right search space. After at last, we can return the answer and we would quickly run this up and we would submit the code. So it runs fine, and you may also code this up and solution yourself. Thank you.